Welcome everyone. In this video, I will be covering section 11.5, which is alternating series. So if you recap the ideas of other videos that we saw earlier in this chapter, we started off with sequence and then we moved to series, understanding what series are, and we saw several series right now, the telescoping series, then geometric series, P series, and then we also learned how to test the convergence or the divergence of a series by some of the techniques in these sections. The techniques that we learned so far are the divergence, test for divergence, um, then, then to understand when geometric series and P series converge or diverge, and then how they can be used in comparison test. Then we saw comparison test, limit comparison test, and also integral test. So all the tests that we have done so far pertain to series of positive terms. So all the terms are positive. Now in this section, we are going to see what an alternating series is, which are combination of plus and minus in the terms. So what is an alternating series? The convergence test that we have looked at so far apply to series with positive terms. In this section, in this section and the next, we'll learn how to analyze the series whose terms are not necessarily positive. Of particular importance are alternating series whose terms alternate in sign. So what is an alternating series? It is a series whose terms are alternatively positive and negative. Here are two examples. You can consider the expanded version of a series with 1 minus 1 half plus 1 third minus 1 fourth plus 1 fifth minus 1 sixth and so on. If you notice, the terms are similar to harmonic series. Only thing is the terms are alternatively positive and negative. Because the terms start with the positive sign and then positive, negative, we are going to introduce this negative 1 to the power n minus 1 times 1 over n. Because when you plug in n equal to 1, you get the first term. When you plug in n equal to 2, you get the second term with the negative sign, and so on. You can also consider the next series, which starts negatively and then alternate in sign. So negative 1 half plus 2 thirds minus 3 fourths plus 1 4 fifth and so on. So it starts negatively, that takes care of this negative 1 to the power n. And then if you look at the numerators, it's 1, 2, 3, 4, 5, 6. So first term has a numerator 1, second term has a numerator 2. Third term has a numerator 3. So nth term will have the numerator n, and denominator is always 1 more than the numerator. So if you look at the denominators, they are 1 more than the numerator always. So the denominator here is n plus 1. We see from these examples that the nth term of an alternating series is of the form a sub n equal to negative 1 to the power n minus 1 bn, or an equal to negative 1 to the power n b sub n. So if we look at only this part, 1 over n or n over n plus 1, they are only the numerical parts of the term. They are positive parts of the term. Only this negative 1 to the power n minus 1 or negative 1 to the power n in the second example associate the appropriate sign. So without that negative 1 to the power n or n minus 1, this Bn is only all positive parts of the alternating series. Where Bn is a positive number, in fact, Bn it would be absolute value of An. So what is alternating series test? If the alternating series sigma negative 1 to the power n minus 1 Bn equal to B1 minus B2 plus B3, etc., alternates, Bn's are all positive. If it satisfies the two conditions, Bn plus 1 is less than or equal to b sub n for all n, which means the sequence bn is decreasing, and limit is n approaching infinity bn equal to 0, then the series is convergent. So bn less than or equal to bn plus 1 less than or equal to bn. This means the sequence bn of positive terms is decreasing. Along with the second condition, limit of the nth term, limit of b sub n equal to 0. So remember, bn's are nothing but the absolute values of the alternating series an. So we have two requirements to use this alternating series. The first one is the decreasing condition. The second one is the nth term being equal to 0, the limit of the nth term being equal to 0. So whenever, even though it is given in this order, it is not necessary that you should always do condition 1 first and then condition 2. Some problems would be easier if you do condition 2 first. The reason being, if condition 1 is true, definitely you have to do condition 2. But for some reason, condition 1, proving condition 1 may require some amount of work in some problems, because it's proving that the sequence is decreasing. It may not be that obvious. Sometimes you have to go for the relating function and do the decreasing test. So instead, if you do condition 2 first, if it is true, yes, you have to go do condition 1. Suppose condition 2 itself fails, then you don't even have to do condition 1. So some problems, it's easier to do condition 2. And if it fails, then you don't even have to do condition 1. Let's say one example here in this part of the video. Then we will try the next two examples in the next part of the video. Is the alternating harmonic series convergent or divergent? Justify. So 1 minus 1 half plus 1/3 minus 1/4, etc., which is written in the sigma form, sigma n varying from 1 through infinity, negative 1 to the power n minus 1 over n. This is an alternating harmonic series. The question is it convergent or divergent? So anytime you see terms with alternating terms with negative 1 to the power n minus 1 or negative 1 to the power n associated, then the series is an alternating series. The given series is, the series is an alternating series. Once you recognize that, you would apply only alternating series test. Alternating series test. So for that, we have two conditions. One, we have to show b sub n plus 1 is less than or equal to bn for all n. What is bn? It is absolute of the ans. So what is an? An is without the sigma sign. Sigma sign, given term. Given series without the sigma. So which will be negative 1 to the power n minus 1 divided by n. So bn would be the absolute value of an, which is absolute of negative 1 to the power n minus 1 over n. This part, which is a negative 1 to the power n minus 1 part, only gives us a negative sign or the positive sign, a negative 1 or positive 1. So this will be just plus or minus 1, depending upon the value of n. If n was odd, then negative 1 to the power odd minus 1 would be even, so it will have a positive 1. So if it was even, then negative 1 to the power n minus 1 would be negative 1. So it will be only plus or minus 1. But anyway, when you take the absolute value of it, it's going to be 1 only. So it's 1 over n. So Bn equal to 1 over n. So Bn plus 1 equal to 1 over n plus 1. In this case, as the numerator is only a constant, it's easy to compare the two. So we can compare the way we normally do. N plus 1 is more than n. N plus 1 is the denominator of Bn plus 1. And this is the n is the denominator of Bn. Take the reciprocal. So 1 over n plus 1 be less than 1 over n. And this is true for all n. So what we have shown is Bn plus 1 less than or equal to Bn for all n. So thus condition 1 is established. Condition 1 is proved. Next, we have to do condition 2, which is limit as n approaching infinity of Bn. So in the alternating series, we have actually established the first part, the decreasing part. We have to do the second part, which is limit as n approaching infinity Bn, which is limit as n approaching infinity. Bn means always positive, which is the positive part of the alternating series, which is 1 over n here. So 1 over a very large number, this is equal to 0 as well. Condition 1 is proved. Condition 2 is proved as well. So the last part is only conclusion. So we have proved both conditions for alternating series, also alternating series test. So by alternating series test, the given series is convergent. Given alternating series, it is convergent. So we will continue with this material in the second part of the video for 11.5. Hope this video helps.